let's start off with giving ourselves a problem. So I'm going to tell you there are some kites. Thank you. And they have ribbons. Kites with ribbons. If you're someone that really likes drawing pictures, then draw pictures. If you're not a picture person, don't do it. It's not necessary. Some people just really like pictures. One kite has 5 ribbons. So 2 kites would have how many ribbons? You got it. 3 kites would have 15 ribbons, and so on. What I would like to know is how many kites could we make with 275 ribbons? How many kites could we make? How many kites could we make with 275 ribbons? Now we could write an equation to help us with this. Some of you don't even need an equation. And I understand a lot of times you don't need an equation. It's just easier to do it your way. But we need to be comfortable with writing equations. And that usually is challenging for a lot of people. So we need 2 variables. We're going to say that K equals kites. R equals ribbons. I always think it's easier when your letters kind of match up with the word that you're actually using. How could we, does anyone want to say how they could write an equation if you know that 5 ribbons are for every single kite? What do you think, Helen? Yeah. Well, let's not use 275. I just only want to use that there's 5 ribbons per kite. So then we could substitute in other things. Emily, what do you think? 5 over 1? We don't really want to make it a fraction if it doesn't have to be. What do you think? What did you say? Okay, what do you think? Yeah. We're not using 275. We're using only the number 5 and K and R. So, Sam, you said 5KR? 5K equals R? Would that work? The amount of ribbons, let's say I had 10 ribbons. We already said 10 ribbons makes 2 kites. So if I put in a 10 right here, 5 times 10 is 2 kites. We're getting close. That's closer to what I'm looking for, but should it be then? We need to do 5 times the number of kites. So if we have 1 kite, 5 times 1, that's 5 ribbons. If we have 2 kites, 5 times 2, that's 10 ribbons. If we have 3 kites, 5 times 3, that's 3 ribbons. So if we wanted to now use this 275, 5K equals 275, then we could solve to find out how many kites that would be. Which would be, does someone already have that? Is it 25? 55. 55 kites we can make with 275 ribbons. All right. So we're going to be looking for we need to know what solution of an equation is. Solution of an equation. You'll see that written a lot in algebra. And we did talk about some solutions yesterday, but it was just one number that we were substituting. But if you have 2 variables, again, if you have 2 variables in the equation, then they'll make the solution to the equation look like an ordered pair. X, comma, y. You've seen those ordered pairs when you were graphing before, correct? Like on a coordinate plane, you put points on the graph. Okay, same type of thing here, all right? So, for instance, my first part is going to be, is the solution 3, comma 10, is this a solution of the equation y equals 4x? How would I figure out if 3, comma 10 is a solution of the equation y equals 4x? What do you think I should do, Skylar? Substitute. Now, the very important thing here is that you're substituting the correct number in the correct spot. So we have to remember always that the first number is the x and the second number is the y. Always. Even when, back when 4th grade, when you were doing the coordinate plane, it was still x, comma, y. It always is. So if we substitute, we get 10 equals 4 times 3. So is it a solution? No. So it's kind of similar to what we were doing yesterday, but just a step beyond. What if I gave you the equation, same solution, the equation, actually, I'm going to do a different solution, sorry. 5, comma 20. And I asked if that would be a solution of y equals 4x. Yes. Because, again, if we substitute the 5 in for x and the 20 in for y, that would be 20 equals 4 times 5. We okay on those? I don't think we need to do as many examples as I wrote down for us. So now we need to talk about making a table, making an equation, making a graph. So let's write down, and I know that you all don't like writing down like sentences in your notes, but sorry. We need to know what the question is to be able to have the example. The example is going to go along with just this one question. Is it easier if I say it or just write it? Okay. Both Carrie's and her sister Kim, both Carrie and her sister Kim were born. Both Carrie and her sister Kim were born on October 25th. But Kim was born 2 years before Carrie. But Kim was born 2 years before Carrie. How can you represent the relationship of Carrie and Kim's age using a table, an equation, and a graph? So we're going to represent the relationship of ages using a table, equation, and graph. Both Carrie and her sister Kim were born on October 25th, but Kim was born 2 years before Carrie. Represent the relationship of ages using a table, equation, and graph. So we're going to start with a table. Now your tables can be situated horizontally or vertically. That is going to be totally up to you. I usually like doing them horizontally because it takes much less room on my paper. So we have Carrie. So again, this is going to be my table. We have Carrie. We have Kim. If Carrie is 1 year old, how old is Kim? If Carrie is 2 years old, Kim is 3 years old, 5, 4, 6. I'll stop in about. That would be an example of making a table. Do an equation. Our table can help us out with writing the equation. Let's say that Carrie is X and Kim is Y. So how could I write an equation using X and Y? And in my main problem, the number was 2 because they were 2 years difference. How could I do that? Some thoughts here. All right, yes. Yep. That would be one way we could write it, yes. Y minus 2 equals X. Sam, did you have a different way? Correct. X plus 2 equals Y. Again, we can double check to see, does our equation make sense by just substituting 2 of the values in to our equation. Carrie is 1 and Kim is 3. 3 minus 2 equals 1? Yes. 1 plus 2 equals 3? Yes. So you can check your equation by using your table. Emily. You could say y minus x equals 2. Just so you know, I kind of usually make my x kind of fancy looking like that so it doesn't look like a multiplication sign. That's why I have it like that. You don't have to do it like that. All right, now, last thing, let's make a graph. So using our table, these are going to be like points on our graph, okay? 1, 3, 2, 4, 3, 5. So I know making a graph in your notes is kind of difficult. I'll help you through it, don't worry. It doesn't have to look perfect. I'll have a little piece of graph paper on your assignment today. So we're just going to be using quadrant 1. You know what I mean by that, right? Okay. Quadrant 1 of the coordinate plane. And we're going to say that down here is going to be Carrie's age. And over here is going to be Kim's age. And in our table, for Carrie's age, we have 1, 2, 3, 4, 5. So that's what I'm going to put down here. Now it starts with 0. Then 1, 2, 3, 4, 5. Now for Kim's age in the table starts with a 3. But can I start my graph with 3? No. It starts at 0. So I need to be 0, 1, 2, 3, 4, 5. And once again, using our table, we're going to plot the points on our graph. If Carrie is 1 year old, Kim is 3 years old. Carrie is 2 years old, Kim is 5 years old. Carrie is 3 years old, Kim is 7 years old. Shouldn't your points be making a straight line? And again, I know that it's in your notes and it's probably not perfect, and mine is not perfect either. But it should be pretty close to making a straight line. So there would be your example of a graph. So we showed the relationship using a table, we showed it by writing an equation, and we showed it by using a graph. So for your assignment today, you're going to have 2 separate problems. I've given you space on the paper to make a table, given you space to make an equation, and I've put graph paper on there so that you can make a graph. Okay? Any questions for us?